of three-dimensional figures of solids. This one happens to be a sphere. It might be kind of hard to see, but it's supposed to look three-dimensional in that picture. If you can see the shaded oval, it's supposed to be giving you that the great circle in there, the biggest circle in a sphere, right through the middle, right through the circumference around the outside. That is a sphere. It's three-dimensional. I hate it when people call them circles, because they're not circles. If it's a ball shaped, it's a sphere. A circle is flat. That is flat, like you can cut a piece of paper into a circle. But a ball that you throw is three-dimensional. That is a sphere, okay? It's a set of all points in space that are a given distance from a point known as the center. So everything, not just in a plane, it's in space. A plane is two-dimensional, space is three-dimensional. All right. There's a, if you wanted to Google a video to explain exactly how they derived this formula, you're more than welcome to, but I'm not going to take the time to do it in this video. I'm just frankly going to give you the equation. The equation is easy in that we only need one measurement, the radius. It's hard in that 4/3 is something you have to put in either as a fraction or multiply 4 times pi times r cubed and then take that answer divided by 3. It's just, you can't do 1.33333 and expect to have the right answer. It's just not going to work. It's important that you have a calculator that you are comfortable with. My recommendation would be a calculator like this, because I know how to put fractions in there, and it also has a pi button. But whatever you have, as long as you get comfortable with it, is the way to go. All right, so here it is. Here's the equation, 4/3 times pi times radius cubed. We are cubing it. So some of you might have a calculator that has a cube button. Most of you are probably going to have to use this caret button right here to put that exponent in, and I'll show you how to do that. And then hit equals and then round it, because when you get pi, it's irrational, so you're going to have to round it to the nearest whatever they give you. In this one, it says 10th. Most of the time, it's 10th. If they don't tell you what to round it to, assume it's 10. Remember, we can still leave things in terms of pi a lot of times because of this 3 in the denominator. You may also have a fraction out in front of the pi, and that's okay. So let's practice that. Notice for each one, I not only have an exact answer, but I have an approximate answer. So I'm going to require both of those for you. Take a look at A. You'll notice that it gives the whole diameter. If the whole line across is drawn in there, that is the diameter, which means our radius is 11. So our volume is 4/3 times pi times 11 cubed. Okay, so I'm going to take in my calculator 4/3 times 11 raised, check that out, to the 3rd power. So that's a fraction, 4/3 times 11 raised to the 3rd power. That's what that caret gives me. And this will give me a fractional answer. Okay, oh, just kidding. Let me see if I can't make that work out a little better for us. So I'm going to put that in parentheses. I'm going to go 4/3 times, oops, close my parentheses, times 11 to the 3rd power. Well, geez. So let's see here. 11 to the 3rd power. I think it's giving me, because it is so big, the number is so big, and then I'm going to take it times 4. So I'm going to get 5,324 over 3 times pi. So 5,324 over 3 times pi, and then times pi. You're probably thinking, how did I do that? I get my answer, 16,725.8 centimeters cubed. Okay, so what I did there is I took 11 cubed and I multiplied it by 4, and I just left it over 3. Let me show you what I mean by that, all right? So there's my two answers. Let's do this one. 4/3 pi times 5 cubed, okay? I know 5 cubed is 125. If you're not sure of that, just 5 times 5 times 5, you get 125. So 4/3 times pi times 125. I'm going to take 4 times 125, and you should get 500. So I'm just going to multiply all that up here. 4 times 125. I get 500 over 3 pi. Sorry about that. And that is my exact answer. Then I actually punch that in, and I get 523.6 millimeters cubed. All right. Slide over here on, and there's really nothing else to work on. It is one equation, and the equation requires one number. So how do they make it harder? They give you a word problem like this. It says a volleyball has a diameter of 10 inches, which means our radius is 5, right? A pump can inflate the ball at a rate of 325 cubic inches per minute. How long will it take to inflate the ball? So first find the volume, and then I would divide it. So first find the volume of the, this is how the book did it, but I'm going to show you how I would do it. Find the volume. So 4/3 pi 5 cubed. And if I'm not asking for an exact answer, I can just do that. 4/3 times pi times 5 cubed. And I'm going to get 523.6 centimeters cubed. And if that's how many total cubic centimeters, and I can inflate it at a rate of 325 per minute, I'm just going to divide that answer by 325 and find out about how many minutes it's going to take to do this. And if you do that, you get 1.6. Now, it's interesting that the book sets up a proportion, and you could do that. But if they're going to give you per one, I would just divide. If they're going to give you a unit rate, I would just divide. All right, let's practice another one of those. On the back side, a snowball has a diameter of 6, which means its radius is 3, right, centimeters. How long would it take a snowball to melt if it melts at a rate of 1.8 cubic centimeters per minute? Once again, it's a unit rate. So I'm going to find the volume and just divide it by 1.8, because every 1.8 cubic centimeters takes a minute. So my volume is 4/3 pi times 3 cubed. Okay, so 3 cubed times 4/3 times pi gives me volume approximately 113.1 cubic centimeters. And then divide by 1.8. And you guys, I did that on my calculator. I know I wrote it down, and I rounded as I wrote it down, but I left that number in my calculator, and I found a closer answer. So it takes me 62.8 minutes for that to melt. So a little over an hour. That doesn't sound, 62.8 minutes, it seems like a long time, but when you think about it, a snowball taking just a little bit over an hour, that's not that bad, right? Because it does take a little bit. Okay, a hemisphere. Oh, I lied. It does have one step harder. So a hemisphere, that's half of a sphere. So guess what? Find the volume, cut it in half. But for those of you who are fraction people, if I have 4/3 and I multiply it by 1/2 and I cross reduce, guess what? The equation is 2/3. But do you have to do it that way? No. You can do it using the equation. So exact answer. Notice this is all the way across, which means my radius is 1. So 4/3 pi 1 cubed times 1/2. Okay, so guess what? In here, 1 cubed is still 1. I got 4/3 pi times 1/2 out front. I got 2/3 pi for an exact answer. And then when I round that, I get 2.1 centimeters cubed. All right, F 9 meters, so 1/2 times 4/3 pi times 9 cubed. So I'm going to take 9, I'm going to cube it, take that times 4. And I know that's divisible by 3, you got to get a 9 in there. So I got 1/2 times 972 pi. So I got 486 pi, and then when I multiply that by pi, I get 1,526.8 meters cubed. All right, keep going. Find the volume of each. 10 is my radius, so 4/3 pi times 10 cubed. 10 cubed is 1,000, so basically I have 4,000 over 3 times pi. Well, 4,000 divided by 3 times pi gives me approximately 4,188.8 feet cubed. All right, next one, I have 4/3 pi times 6.5 cubed. So 6.5 cubed times 4 divided by 3. I don't like this as an exact answer, so if I'm going to ask for an exact answer, it's going to be something that's reasonable to write. Okay, so there's that one. All right, so number 3, Sarah's blowing up balloons. One of the balloons has a radius of 3 inches. Round to the nearest tenth. So first, what's the volume of the balloon? All right, well, 4/3 pi 3 cubed. Guess what? 3 cubed is 27. So I got 4/3 pi times 27. I can divide that and get 9. 4 times 9 is 36 pi. And 36 times pi, yes, I did that all in my head, kids. 113.1 inches cubed. And if she can blow it up at a rate of 200 cubic inches per minute, how long is it going to take her? Well, less than a minute, right? If I take 113 and divide it by 200, which makes sense, it shouldn't take you more than a minute. So 0.6 minutes. If you want to be exact, about 34 seconds if you take it times. All right, hemispheres, 1/2 of 1. Exact answer, so 1/2 times 4/3 times pi times 8 cubed. So if I multiply that, 8 cubed gives me 512 times 4. So I get 2,048 over 6 pi. Doesn't come out right, but I can take a 2 out. So I get 1,024 over 3 times pi. So 1,072.3 inches cubed. And the second one, my radius is 7.5. So 1/2 times 4/3 times pi times 7.5 cubed. 7.5 cubed is going to give me an ugly answer. So times 4. So I'm going to get 1,687.5 over 6 pi. That's ugly. And then, so I could do this. I could do 281 1/4 pi. And I get 883.6 millimeters cubed. All right, you may need some further explanation on the exact answers. I hope that on your worksheet it won't be too difficult. Some of these were a little bit ugly, but it's doable. The biggest thing is to get comfortable with your calculator. If you need to come and see me for some help, please do that.